Welcome everyone. We are discussing probability. Today I will give definition of probability. Classical definition of probability. Now to give definition of probability, we have already defined some terms, that is random experiment, outcomes, sample space, event. So using these definition, today I will define classical definition of probability. So before discussing it, I am taking an example, simple example. Suppose two coins are tossed. Two coins are tossed. So we know what is the sample space. I have already defined what is sample space. HH, HT, TH and T. This is sample space. Now I have defined what is event. Let A equals to event of one head. So it is subset of sample space. This one is subset. Now one head, you look, this is HT and TH. So what is probability of getting two heads? Probability of getting two heads. So PA equals to probability of getting one head, not two heads, because A is defined as one head. Now, what are the favorable cases for A? 1 and 2. That is, favorable cases is 2. And sample space, total number of outcomes, 1, 2, 3, 4. So 2 by 4 equals to half. So two coins are tossed. So this is sample space. A equals to event of one head. So this is A. So what is PA? Probability of getting one head. So favorable cases for A by total number of cases. So now what is favorable cases of one head? This is 1 and 1. This is 2 and total number of outcomes, that is 4. So what is PA? PA equals to half. Now I will give classical definition of probability. Let a random experiment has n outcomes. Those are equally likely. This is equally likely and exhaustive. I have already defined what is random experiment, what is outcome, what is equally likely and what is exhaustive. Let A is any event associated with random experiment and M equals to number of favorable cases for A. So in the previous example, what is a event of getting 2 heads? And what is number of favorable cases? 2. So what is PA? PA equals to M by N. So what is M? Total number of outcomes of A, Na by Ns. So we can write also in this form Ma, Na by Ns. N, cardinal number of elements of A by number of elements of sample space. So in language, you can write favorable outcomes by total number of outcomes. Favorable outcomes by total number of outcomes. So this is our definition. Let a random experiment has n outcomes. What is our assumption? Those are equally likely and exhaustive. That is why we have already defined what is a random experiment, what is outcome, what is equally likely and what is exhaustive. Let A is event. A is any event associated with random experiment and M equals to number of favorable cases of A. So PA equals to M by N. So Na by A, Ns. N, number of elements of A by number of elements of S. So this is our definition. Now note, 0 lesser than equals to PA, probability cannot be negative. It lies between 0 to 1. Now if PA equals to 0, then A is called impossible event. Impossible event. And if PA equals to 1, then A is called sure event. Sure event or certain event. So what is impossible event and what is certain event? Take an example. So suppose a die. We are discussing the basic problem. A die is thrown. Find the probability of getting eight. Number 2, find the probability of getting even number or odd number. Odd number. So look, we are considering simplest problem. So what is sample space? Introductory class of class 10 or 11. Sample space is 1, 2, 3, 4, 5, 6. For a die, 1, 2, 3, 4 or 5. 5, 6. Find the probability of getting 8. So A equals to probability of getting face as 8. So look, there is no 8, so 0 by 6 equals to 0. Favorable cases, no favorable cases, and total number of cases equals to 6. So here PA equals to 0. So A is called here impossible event. Now B equals to, if we take event of getting, this is not probability, A equals to event, sorry, event of getting even number or odd number. So even number 2, 4, 6 or odd number 1, 3, 5. So what is PB? Number of outcomes, number of elements of B. So 1, 2, 3, 4, 5, 6 and total 6. So this is 1. So here B is called sure event. So this to be noted. So probability lies between 0 to 1. It cannot be greater than 1. So this to be noted. Now A bar equals to event of not getting A bar or A complement, A bar or A complement or A dash, event of not getting A. So P A bar equals to 1 minus PA. I will define it, how it comes. PA bar from addition theorem of probability. So PA bar equals to 1 by 1 minus PA. PA, probability of happening A, and PA bar, probability of not happening A. So consider a problem. The odds in favor of an event are 3:5. are 3:5. Find the probability of occurrence of A. Find the probability of occurrence of A. This is 1 mark problem. Odds means here chance. So chance in favor of A is find the probability of occurrence of the event. Here it is not A. Occurrence of the event. So odds in favor, that is the first one, and 5 is against. So odds in favor, number of outcomes in favor of A equals to 3x. Number of outcomes against A, that is A bar, it is I base. So total outcomes total outcomes equals to 8x, 3x plus 5x. So what is PA? 3x by 5x. So 3 by 5. And probability of not happening A, if you calculate PA bar. So 5x by 8x. So 5 by 8. Here you have to find the probability of occurrence of A. Today I will consider only the simplest problem. Now PA equals to 5 by 8. So odds in favor. Now the reverse problem. Probability of an event A is 3 by 5. Find odds in favor and against A. So this is reverse problem. So PA equals to 3 by 5. Now 3 is favorable. So odds in favor equals to 3x. Total outcomes. Now 5 is not against. So this is 5x is total outcome. So odds against A. Against A. Total outcomes minus favorable outcomes. So 2x. It is obtained at 5x minus 3x. So 2x. So what is odds? Odds in favor of A. In favor of A equals to PA is to PA bar. Favor, it is given favor. So PA is to P bar. So 3x is to 2x. So 3 is to 2. Odds against A equals to PA bar is to PA. So 2 is to 3. So it will be reverse. So basic 1 mark problem. So probability is given. You can find odds in favor of A, odds against A. And second one, odds are given. You have to find probability. So what is classical definition of probability? So PA equals to M by N. So favorable event outcomes by total number of outcomes. Now limitations or drawback. Limitation of classical definition of probability. Probability. Limitation or drawbacks. So one drawbacks. So this is very simple. So NA by NS, favorable outcomes by total number of outcomes. Now if total number of outcomes is not finite, then you cannot calculate PA. So this definition fails if total number of outcomes is not finite. Is not finite. So you can say at least one. This one. This is very simple. Now look at the definition. Let a random experiment has n outcomes. Those are, there is assumption, equally likely and exhaustive. Exhaustive. So this is our limitation. So if outcomes are not equally likely and exhaustive, this definition helps. So this definition based on some terms. For example, equally likely, exhaustive, unless these conditions are not satisfied, classical definition helps. So it has only limited applications. For example, tossing of a coin, throwing of a die, drawing a card from a pack of 52. So those are equally likely and exhaustive. So these definition based on some terms, for example, equally likely, exhaustive. Unless this cannot be done, this definition is not useful. This definition helps. So classical definition and its drawbacks. Now today I will solve some simple problem. First I will solve basic one, then problems of competitive exam. Next, now we consider one problem, simplest problem of class 10 or 11. 3 coins are tossed once. Find the probability of getting one head, at least 2 heads, and at most 2 heads. So first you have to find the sample space. So 3 coins are thrown. So I have already discussed it. So it is 2 to the power 3. That is 8 cases, 3 heads, 2 heads. Yes. Look, first head, second head, third tail. First head, second tail, then head. They are different. Look, this tail is appearing third time, tail is appearing second time. Then 2 tails. And 3 tails. So this is our sample space. So it will be simple if you write the sample space if possible. A equals to event of 1 head. Not 2 heads. This is 2 heads. 2 heads. The event of getting 2 heads. Two heads. So what are the events? 2 heads, HHT, HTH, PHH. So what is PA? Favorable outcomes. So 1, 2, 3 by total number of outcomes. So PA equals to 3 by 8. Now suppose second one is B. At least 2 heads. Look at the language. At least 2 heads. This means at least 2 heads means 2 heads or 3 heads. So 2 heads we are already considering it, and 3 heads H, H, H. So what is PB? So 4 by 8. This is half. Favorable outcomes 4 by total number of outcomes. Now number 3. C equals to event of getting at most 2 heads. At most, means maximum 2 heads. So no head, 1 head and 2 head. So these are the possible cases. Event of getting at most. Look at the language. At most, maximum 2 heads. So maximum 2 heads. HHT, HTH, THH. Maximum 1. That is, you can take 1 head also. So 1 head. 1 head. Look, it is 1 head. TTH, 1 head. THT, HTT, 1 head. And no head also possible. No head means all are 12. So this should be noted. Maximum 2 heads means 2 head, 1 head or no head. No head means 3 tails or no head. So what is PC? PC equals to 1, 2, 3, 4, 5, 6, 7. 7 by 8. So this is simple problem of class 11 or class 10 also. In class 10, problems are restricted for throwing die and coins. So no use of using concept of permutation and combination. Next one. Now I consider one more problem, most important problem also. 2 dice are thrown. Find the probability of getting doublets. A total of 10. A multiple of 2 in one dice and multiple of 3 on other. The sum as prime number. Now I have already discussed total number of outcomes for 2 dice. So 6 square, 36 cases. So here sample space has 36 cases. So you can write, or you have to remember the sample space in your mind. So you know 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Then second is 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Then 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Then if it start with 4, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, and 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So these are the cases. 36 cases. Not mandatory to write the sample space. You have to remember it. No need of writing. Now look, you have to write the events. A equals to event of getting doublets. Doublets means same phase in each die. So what are the doublets? Same phase. So 1 1, 2 2, 3 3. So this is simplest problem. 4 4, 4 5. Sorry, 5 5, 6 6. So same phase in each die. So what is PA? PA equals to 1 2 3 4 5 6. Favorable case by total number of case 1 by 6. Mind it, in case of solving problem, you have to write the event, that is doublets. Now second one, a total of 10. A total of 10. B equals to event of getting total of 10. Total of 10. So 10, sum is 10. So in first row maximum 7, second row maximum 8, third row maximum 9. So 10 is 4 6, 5 5, and 6 4. So this is the favorable cases for sum of two phases as. So what is PB? 3 by 36. So 1 by 12. So this is PB. Now this is also very simple. Now third case, a multiple of 2 in one die and multiple of 3 in other. So write, so call this event as C. Event of getting multiple of 2 in one and multiple of 3 in other. So multiple of 2 means 2 4 6. So multiple of, so if it start with 2 and other is multiple of 3. So 2 3, 2 6, 2 3 and 2 6. Multiple of 2, 2 3, 2 6. Then 4 3, 4 6. Then 6 3, 6 6. So look, it is not given that multiple of 3 in first die and multiple of 2 in first die and multiple of 3 in second. Then you are getting these cases. But here it is not mentioned. It is given that multiple of 2 in one die. So you can take the reverse one also. 3-2, 6-2, 3-4, 6-4. Then 3-6, 6-6. So what are the cases? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So PC equals to 12 by 36. 12 by 2-3-2-6, 4-3-4-6, 6-3-6-6. Then multiple of 3 in the first die. So 3-2, 3-2, 3-2, 3-4. Okay. Three, 3-2, 3-2, 3-2, 3-4, 3-6, and 6-2, 6-4, 6-6. So this is 1 by 3. 1 by 3. Now last one. Event of getting, suppose this one is D. Event of getting sum as prime number. So prime number, sum as prime number, you know, 2 is prime, 3 is prime, 5 is prime, 7 is prime, 9 is not prime, 11. So event of getting sum as prime. So sum as prime. So sum of two faces is 2. So you are getting 1. No cases. Then sum as 3. Look, 1, 2 and 2, 1. 1, 2 and 2, 1. Then sum as 5. So 1, 4, 2, 3, 3, 2, 4, 1. Then here it is 6. Then 7. 7 is 1, 6, 2, 5, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. And finally 11. 11. 4, 6, 10. So 5, 6 and 6, 5. So how many cases? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So PD equals to 15 by 36. So 5 by 12. Now this is most important problem. Sum as prime number. So prime number 2, 3, 5, 7, 11. 13 is not applicable because maximum sum is 12. So look, you write all the sample points of favorable cases. So if you omit one, then it will be other. How many cases? 15 cases. So PD equals to 5 by 12. So this is most important problem. So it is problem of WBJE also. Now we consider one more problem. A coin is tossed If head comes, then a die is thrown. But if tail comes, the coin is tossed again. Find the probability of getting two tails, head and even number. So our main aim is to find the sample space. Now what is the sample space? A coin is thrown, so you can get head and tail. If head comes, a die is thrown. Suppose for the coin we are getting head. Then a die is thrown. So what are the possible cases for throwing die? So we can get head first, then H1, H2, H3, H4, H5, H6. Head, then 1 or 2 or 3 or 4 or 5 or 6. If tail comes, then a coin is thrown again. If we get tail, then a coin is thrown, head and tail. So you are getting, this is T, TH and TT. So these are the possible outcomes. So this is sample space. So sample space has 8. So 8 points, 8 outcomes. Now A equals to 2 heads. 2 heads. So look, 2 heads. So look, there is no 2 heads. So this is 0 by 8 equals to 0. So B, 2 tails. Oh, sorry, this is not 2 heads. It is given that 2 tails, 2 tails, 2 tails, 2 tails. So you are getting only one cases. So TT. So PA equals to 1 by 8. PA equals to 1 by 8. Now head and even number. B equals to event of getting head and even number. So H2, H4, H6. Event of getting head and even number. So what is PB? 3 by 8. PB equals to 3 by 8. So your main aim will be to find the sample space. So these are simple problems. So today I have discussed classical definition of probability and its simple application. Now from next class I will solve problems of probability using classical definition. So thank you for today.